We have already discussed in the video lecture of series combination of resistors that for any series combination of resistors, the current is the same through each point in the series combination, and the voltage is divided across each resistor according to the resistance value of the resistor. Now, the larger is the resistance value, the larger would be the voltage drop across that resistor. Now, one way to find out the voltage drop across each resistor is to find out the total current in the circuit and apply the Ohm's law. So according to Ohm's law, to find out the voltage drop across the R1, V1 will be equals to I into R1, where I is the total current in the series circuit and R1 is the resistance value of the first resistor. Now the same is for V2, would be equals to I into R2, and for the third resistor, V3 would be equals to I into R3. Now, in order to prevent ourselves from finding out the total current in the circuit, we can use a rule called a voltage divider rule, which states that the voltage divider rule permits us to find out the voltage drop across each component without finding the total current in the series combination of resistors. Now, by without finding the total current in the circuit, we means that this voltage divider rule prevents us to find out the total current in the circuit. Now, as we know that the total current in the circuit is equals to E, the input voltage to this series circuit, divided by the total resistance or the equivalent resistance of this series circuit. So, the equivalent resistance of this series circuit is equals to RT is equals to R1 plus R2 plus R3. Now, in this equation, instead of I, we can write down this equation, which is V1 would be equals to, instead of I, we can write down E divided by RT, where E is the total input voltage to this series circuit and RT is the equivalent resistance of this series circuit into R1. And similarly, V2 would be equals to, instead of I, we can write down E divided by RT into R2. Now, instead of V3, we can write down V3 is equals to E divided by RT into R3. Now, if there is n number of resistors connected in series, to find out the voltage drop across the n number of resistors, so Vn would be equals to E divided by RT into Rn. So this equation represents the general formula for the voltage divider rule, where E is the total input voltage to this series circuit, RT is the sum of all the resistances connected in series, where this Vn is the voltage drop across the Rnth resistor, and E is the total input voltage to this series circuit, and RT is the equivalent resistance of this series circuit. Now, to understand this voltage divider rule in a more brief way, let's take a simple example in which we have a DC voltage source which is connected in series with three resistors, R1, R2 and R3. R1 is 6 ohm, R2 is 3 ohm and R3 is 1 ohm. And the potential difference across the terminals of this DC voltage source is 20 volts. Now, if we are asked to find out the total voltage drop across R1, R2 and R3 by using the voltage divider rule, so by using this formula, we can easily find out the voltage drop across each resistor in this series circuit. Let's say the voltage drop across R1 is V1, the voltage drop across R2 is V2, and the voltage drop across R3 is V3. So first of all, we need to find out the equivalent resistance of this series circuit. So the equivalent resistance RT is equals to R1 plus R2 plus R3. So RT would be equals to 6 plus 3 plus 1. So RT in this case is equals to 10 ohms. So the equivalent resistance of this series circuit is 10 ohms. And the input voltage is given to us, which is E is equals to 20 volts. So by using this formula, we can easily find out the voltage drop across each resistor. V1 equals to E divided by RT into R1. So E in this case is 20 volts divided by RT is 10 ohms, and the resistance value of this first resistor is 6 ohms. So after calculating this, we get V1 is equals to, so 0 will cancel 0, so V1 is equals to 12 volts. So here we have 12 volt of voltage drop across this R1 resistor, and the voltage drop across R2 is, let's say V2 is equals to E divided by RT into R2. So E in this case is 20 divided by RT is 10 ohms, and R2 is 3 ohms. So 0 will cancel 0. So V2 in this case is equals to 6 volts. So here we have 6 volt of voltage drop across R2, and the voltage drop across R3 is, let's say V3 is equals to E divided by RT into R3, where E is 20 volts divided by RT is 10 ohms, and R3 is 1 ohm. So the resulting voltage drop across R3 is equals to 0 will cancel 0, so 2 volt is the voltage drop across the third resistor. So it's all for today's presentation. In the upcoming presentation, we will be discussing another example related to the voltage divider rule. So see you in the next one.